I'm Gideon Wolfaardt from Stellenbosch University. There we have a water institute which I'm the director of. And so my role in the project is twofold, is to basically spread the project, give it reach in South Africa, but also to overlook two technologies which we can look at on the project. So the Demosite is in Cape Town. It's in the Cape Town area. So Cape Town is the southern part of South Africa, and that's a city who had in 2018. You saw quite a number of articles in newspapers worldwide on Cape Town was facing day zero, which means we were going to run out of water. And that was a serious concern, which is not unusual because quite a number of other cities in the world have the similar problems, across different continents. So there's population growth, there's urbanization, all of these contribute to lack of water. And so in the case of Cape Town, they looked at planning for new water, if you can call it like that. So we have a finite water resource where we're going to find new water to deal with climate change, the differences we can find in water supply, increased population, and as a result of that, limiting water resources. So one of those would be to look at the aquifer, which is underground storage, if you can like, in the Cape Town area. Is quite a large one. And in the planning is to have about 15% of this new water that the city of Cape Town wants to find. And by the way, the city of Cape Town is a large area, it's about 5 million people, but the city itself is more than 1 million people. Where do you find this extra water you need? And so in the case of Cape Town, this aquifer we're talking about, the Cape Flats aquifer, is about, we're looking at almost 15% of the new water over the next 5 to 10 years should come from this aquifer. Now the problem is, if you extract too much water from that, we're on the coastline, west and south, you get saltwater intrusion from the ocean into this aquifer, this underground lake, if you like. So we have to limit that. To counter that is to use treated wastewater and stormwater runoff and recharge this aquifer. So, and then the challenge with that is the quality of the water you put back into this underground storage should be of sufficient quality. And that's what we are looking at, how to prevent it. In our case, we're looking at nutrients from fertilizers, from agricultural production. There's also a large food producing area above this aquifer. So when you apply fertilizers, you see leaching of specifically nitrates and phosphate into the groundwater, which is not good for the water quality. The other aspect is, how do we know all these actions taking place and all the pollution that's happening, that the quality of this water which we put back into the system will be sufficient for providing drinking water again for this community, for the society. And so for that, we're developing, our part in the project is developing a sensor to look at impact on living organisms in real time. So one of our technologies is to apply novel ideas how to get better uptake of the nutrients, of the fertilizers. So farmers can use less fertilizers, less pollution to the groundwater, also saving on fertilizer cost, which saw a huge, more than 100% increase over the last 2 to 3 years, the cost of fertilizers globally. The project is to ensure sustained water supply from underground resources, in this case aquifers.